desmos. All right, now tell me, we're going to solve this equation. You guys are going to notice these are not in the format we had yesterday. These are not something that we're going to factor. We have an x cubed minus 5x squared minus x plus 5. So it's not in the format that we were looking at yesterday, which was a quartic that was similar to a quadratic that we could factor. So these are totally different. But I think you could tell me, like, how many answers should I have to this question? Okay, so I have 3 answers. So if it's not something that when you look at it, you're like, oh, I could factor that really easily. So we're going to try to break this down so we can use the zero product property into factors. We have to break it down to at least quadratic factors. So if we can't factor it, which at the moment I can't factor that, what I want to do is I'm just going to put this on Desmos and graph it. What I want to do, though, is where it has a 0, I'm just going to put a y, and we'll just look for where it crosses or touches the x-axis. So we're just typing in x cubed. And remember, on the computer, to get the exponent, if you hit shift and the number 6, that'll give you an exponent, and then you can just use the arrow key to arrow out of the exponent. So just shift and 6 to get an exponent. Or you could, there's a little keyboard down there if you want to use that, you could do that too. You do not have to log into this or anything, it'll work, it's totally free. And remember, if you want to kind of like scrunch the x or y axis with your fingers, you can kind of manipulate the screen since you guys have a touch screen. I'm just kind of messing around with mine. How many answers do you see on that graph? You see, and I'm supposed to have 3, right? So if you, remember, if you actually click on the graph, and you can also click on these points, but if you just click on the graph, it should automatically identify any critical points with kind of like a little grayed out dot. If you actually click on the dot or hover over the dot, it will actually tell you the point. Now, these are all nice answers, and so I'm just going to write those down. So I have -1, 1, and 5. I have all 3 of them. They're all real. I can see them all on the graph. We're done. That's it. That's all you have to do. Now, they're not all going to be that quick. You're going to see I've got some space. So if it's not nice numbers, right, if it's not a nice number, if you have a nasty decimal or something, we're going to show you how to do that in the next question. Okay, so the next question, very similar, but I got a little bit different terms in my polynomial here, so I'm just changing this up. And you could edit the equation you already had, or you can type over the top of it, whatever you want to do. I just did y equals, and then we're looking for where the graph crosses the x-axis. And I know this one's going to have 3 answers because my highest power of x is to the 3rd. If you come over here, though, and click on these, if these are nasty numbers, we want, oh my gosh, sorry, I keep left clicking on them. All 3 of them are real. We can see them all on the graph. But if you've got a nasty number, it's going to want you to write the answer in either simplest radical form or kind of like we did when we broke down a quadratic equation. But at least one of these is a nice answer, right? At least one of them is a nice answer, which is 3. So I know 3 is a solution right away. So the other 2 are both real numbers. Let me just go over to my note paper real quick. I want to try and write the exact answer that I had there. If I know 3 is a solution, which I do from the graph, how could I use that to help me maybe break the polynomial down? Exactly. So if 3 is an answer, that means x minus 3 is going to be a factor of that polynomial. All right, now, it's totally up to you guys, but we're going to just use division to break it down. So you can use long division if you like that, or you can use synthetic, either one, but we're going to break the polynomial down into factored form by getting that 0 or that solution from the graph. You just have to write the corresponding factor. Okay, I'm going to use synthetic because I think it's just a little bit faster. So all I'm going to do, I'm going to change up, and actually you could just write the 0 if you want to, which is 3. The linear factor would be x minus 3. Write down your little coefficients. So 1, -3, -2, and 6. We're not missing any powers of x or anything weird like that. All right, very first step is to just bring down the first coefficient and just copy that beneath the line, and then that starts the whole process. Do you guys remember doing this the other day? Like, how do I, like, what do I do next? Okay, multiply by 3 and put it where? Good. So you just multiply here and put it in the next open spot. So 3 times 1 is 3. And you just add the numbers that are stacked on top of each other. So actually that's just 0. And then just repeat. So then I'm going to do 3 times 0, which anything times 0 is 0. This will be -2. Now, should I have a remainder? No, you know that up front because you know this is a factor, because you know if you know that's a factor, you should not have a remainder. So if you get a remainder, you know you made like a little mistake somewhere along the way. So then I'm doing 3 times this -2, which is -6, which means my remainder is 0. Okay, now here's what we have done. We divided x minus 3 into that polynomial. So that means the factored form of this, x minus 3, and then my remainder is 0, which it should be. My constant or my plain number, please don't forget to put a number. Sometimes people will just go remainder and x. Don't do that. So plain number, then x, which we don't have an x, and then x squared. So then when I divided that in, what I got was x squared minus 2. All right, we know this is supposed to have 3 answers, right? We already got the one from the graph, the 3. From this, you'd have x squared minus 2. If that was equal to 0, that's going to give us our other 2 answers. So this is similar to yesterday. You're just going to add 2, and then we'll take a square root there. And I'll go back to the graph in a second to show this to you guys. The other 2 answers plus or minus the square root of 2. So we have 3, and then we have plus or minus the square root of 2. So let me just pull the desmos back on the screen here, so you guys probably have it up on your computer to look at anyway. So do you see that decimal that I got there? If you actually take the square root of 2 on your calculator, and maybe have your teacher display it on the screen so you can actually see it, you're going to see that'll match up with that decimal. One is positive of that, and one is the negative version because I had the plus and minus, but that's where that comes from. So if you don't have nice numbers like we did in the very first question, we're just going to use the graph to get a 0 that's at least a nice number and then start to break it down. So I have 3 answers there, the 3 from the graph, and then plus or minus the square root of 2, which we could see that on the graph, but we didn't know exactly what that was because it gave us a nasty decimal. Okay, so now I'm going to try another one with you. Each one of these is just a little bit different. So let me pull my graph up here. And again, you can type over the top or kind of edit. It's however you want to do it, or you can start from scratch. It's completely up to you. This one is x cubed minus x squared minus 15x minus 25. And immediately, all these guys on the front of this side of the notes, these are all cubic polynomials. So highest power is 3. So I know for each one of these questions, I'm supposed to have 3 answers. Okay, how many answers do you see on that graph? Just 1. All right, what does that mean? And we can get it. I'm just going to, whoops, I'm going to stop left clicking here maybe. There we go. So 5 is our answer here that I can see on the graph. So one of the answers is 5 right away. If I can't see any other answers on the graph, what does that mean about the other answers? They're imaginary. Okay, so we're going to do the same thing, but I'm just going to know up front my other 2 answers are going to be imaginary since we looked at the graph there. All right, what would, if you have 5 as the solution, what would the factor be, little linear factor that would go with that? X minus 5, yeah. So that means x minus 5 is going to be a factor of this polynomial. So that's what I'm going to divide it. Okay, so if you want to use long division, you are more than welcome to do that. I'm just using synthetic because it's a little bit faster for me. So either opposite of what it looks like in the parentheses, or the actual 0 is what goes outside if you're doing synthetic division to break these guys down. Coefficients, I got 1, -1, -15, and -25. Just leave yourself a little bit of space, or if you want to do long division, you're going to get the same answer that I'm getting with the synthetic. So if you like that better, you are welcome to do that. Just that very first thing is to just bring down that first coefficient, just bring it down, copy it, and then you can start the whole process where you're going to multiply and then add. So just multiply below the line and put it in the next open spot above. So 5 times 1 is 5, Add that to -1, we're going to get 4. 5 times 4 is 20. Add that to -15, we're going to get 5. And then 5 times 5 is 25. There's no remainder, and there should not be a remainder if that's a factor. If you get a remainder, you did something wrong. The 5 is your plain number. The 4 is going to be attached to an x, and the 1 is going to be attached to an x squared. So what this means, my factored form here, we have x minus 5, and if we multiplied that by x squared plus 4x plus 5, then we would have back the original problem. Okay, now, you might look, I initially look at that and I think, oh, I'm going to think of numbers that multiply to get 5 and add to get 4. But I know I'm not going to do that because the graph did not cross the x-axis in any other places. So that's actually not factorable. So you could, it's up to you, you could complete the square. It would not be bad to do on this if you wanted to set this equal to 0 and complete the square. Or you can just use the quadratic formula. That's what I usually do. It's completely up to you. So I'm going to say let's just use the quadratic formula. That's going to get me the other 2 answers. If you need it, I have it typed at the very top of the note page here. So these are not going to be nice. I know they're going to be imaginary because we saw that on the graph. So I'm going to do opposite of b, -4, plus or minus, square root. B squared would be 4 squared here. Minus 4 is part of the formula for the quadratic formula. The a value is 1, the c value is 5, everybody over 2a, so it's going to be 2 times 1 here. Totally up to you how you want to do it. What I usually do is I do the discriminant on my calculator. So I'm going to do 4 squared minus 4 times 1 times 5, which is going to give me -4 under my square root. What would you write down as the square root of -4? 2i. So that is actually perfect square in imaginary land, so we're not going to have a radical here. And this is all over 2. Now, don't worry about the I. If all, and it has to be all 3 of these numbers have anything in common, you can reduce it, which they do here. So what would my answer be if I simplified that expression? -2 plus or minus I. And that is 2 answers. The other answer was the 5 that we saw on the graph. And then the other 2, so we have 3 answers total. -2 plus I, -2 minus I. You do not need to, somebody asked me yesterday, you do not need to write like -2 plus I, comma, -2 minus I. Just leave it like that. That's why they invented that plus minus symbol, so we can have a little shorthand way of not having to write stuff out so much. Is anybody having a question? Okay. So we're just using the graph to help us break down the polynomial. And now I'm not going to lie to you, these 2 on the back are a little bit trickier. And you'll notice the title of my example says solving a polynomial equation, and it says in parentheses double divide. Alright, so I'm going to look at the graph. And these guys on the back are quartic polynomials. So you got x to the 4th. So each one of the questions on the back are going to end up having 4 answers. And I know that based on the exponent. The degree of the polynomial is the highest power of your variable. So that's x to the 4th. So 4 is going to be my degree. All right, so I'm going to add an x to the 4th into the mix here. So we're doing x to the 4th and then minus 10x cubed plus 19x squared plus 40x. And then, let me scooch that so I can read it, minus 92. Alright, and then you guys can scrunch the graph however you want to. How many solutions are real for this question? All 4 of them are real. Like if you click on the graph, oh, please don't tell me I closed that. Okay, good. Click on your graph, and then it should kind of gray any critical points. Like relative max and min are kind of highlighted too, but we're just interested in the zeros there. Now, here's the deal. 2 of the answers are garbage, right? Because they've got a big, long decimal, so we're going to have to work at getting those in an exact format. Two of the answers, though, are nice numbers. I can see -2 as an answer, and I can see +2 as an answer. We're going to use both of those to put this polynomial into standard form, or into factored form. Okay, so all four will be real, but we have two that are nice numbers. So I had -2. I'm just going to start. It doesn't matter. You can pick either one to start with. If -2 was a 0, what would be the factor that'll go into that polynomial? X plus 2. Perfect. All right, so I'm just going to start there. You could start with the other value that was nice on the graph was +2. You could use that to start. It doesn't matter. We'd end up with the same answer. I'm just going to start with the -2. All right, so if I set up my synthetic division, we'd have 1, -10, 19, sorry, these are kind of big numbers, 40, and -92. Same process we were doing on the front. I'm going to do synthetic division here. So I'm going to take -2 times 1, and that goes in the next open spot there, which is going to give me -2. And you just add that to the number stacked on top of it. So that's going to be -12. Now, don't forget, especially if you're working with a negative, negative times a negative becomes positive. So -2 times -12 would be +24. And then we're doing 19 plus 24, which is 43. And I'm going to multiply that by -2, which is going to be -86. We're going to add that to 40, which is -46. And then remember, if we got this from the graph and it was a 0, we should not have a remainder, which if you do -2 times -46, that is 92. There is no remainder. Okay, now, I'm breaking this down into a product of factors. If we want to label this, right, this would be our constant x squared, we'd have x cubed. What I would tell you to do right from there, just grab the other 0 we had on the graph. The other 0 was 2. And then that factor would be x minus 2. You don't want to go back up to the beginning. You've already divided the polynomial once. Just go ahead and divide what you have left. So I'm just going to use the coefficients that I had from my answer. We're just trying to further, and you don't need to put the 0, just put those first 4. So you broke it down to a cubic function, and this time I'm going to divide in x minus 2, which is going to put a 2 on the outside if you want to use the synthetic. Now, same thing here. This should not have a remainder if you grab the zeros off the graph correctly and you did the synthetic division correctly. So I'm just going to run through here. 2 times 1 is 2. Add that to -12, you're going to get -10. 2 times -10 is -20. Add that to 43, you're going to get 23. And this is perfect. 2 times 23 is 46. No remainder. All right, so I divided twice. This is a little extra here. I understand that. I'm supposed to have 4 answers. I got 2 of them from the graph. The other 2 I saw on the graph, but they were not nice numbers, and we want an exact value here. So what I have totally factored this. We did x plus 2, x minus 2. Both of those factors went in. Our result here, we don't have a remainder. 23 would be your plain number. -10 would be your x, and 1 would be your x squared. So the other factor here, x squared minus 10x plus 23. That is as far as you can factor that polynomial. And we know that from the graph because those other 2 answers were nasty decimals. So, option for you, if you want to, you could definitely do completing the square on this. But I think I'm just going to, I feel like I'm crossing that out, so maybe I'll go back over that. This is going to say x squared minus 10x plus 23. I would just use the quadratic formula again on this. And I know it's not factorable, because if it was factorable, we would have had nice answers on the graph. So I would just use the quadratic formula. I also know these should be real numbers. We should not have I involved because we saw it cross the x-axis on the graph. We do have 2 of the 4 answers from the graph, the -2 and the +2. We'll get the other 2 from doing that quadratic formula. So opposite of b there would be +10 plus or minus square root. -10 squared 4 times 1 times 23. Everybody over 2a, so just 2 times 1. Let's figure out what's under that square root. I got 10 squared minus 4 times 1 times 23. And so I get 10 plus or minus, I just ended up with 8 under my square root here, and then that was over 2. Now, 8 does break down under a square root. Biggest perfect square that goes into 8 is 4. So I would just think about that as 4 times 2. The square root of 4 is 2, and then radical 2 there. So this would be 10 plus or minus 2 roots of 2, everybody over 2. And then if you can, it has to be all 3 of these. Don't touch the radical. All right, not the radical, not involved. 10, 2, and 2, all divisible by 2, yes? So you can actually divide that. So the other two answers, 10 divided by 2 is 5. Now, 2 divided by 2 is just, I'm just going to lightly write a 1 in here, but typically you would not see that, but it would still have a square root of 2. The answer there would probably just be written as 5 plus or minus the square root of 2. Now, this is the other 2 answers. So, let me, here, I'm going to slide this to the side just so I can show this to you. If I pull the graph back up real quick, so you guys can see those decimal places. So you see one of them is like 3.58, whatever. If I do, am I on the screen? Of course I'm not. If I do 5 minus the square root of 2, that gives me that 3.5 whatever decimal. If I do 5 plus the square root of 2, that's going to give me that 6.4 decimal. So that's what you're finding by breaking it down and using the quadratic formulas. You're finding these exact answers. Okay, let's try one more. This last one's also quartic, so we're going to have 4 answers. You've got x to the 4th minus 3x squared plus 53x, or sorry, x cubed for that last one. 53x squared minus 243x, and then huge number, 2,268. Alright, I'm going to scrunch this a little bit. And this is sort of like a weird looking, it's not a parabola because it's to the 4th power. It does not have symmetry like a parabola would. But how many answers can I see on the graph? So that means the other 2 have to be what? Imaginary. Alright, so these are both nice numbers if you grab these off the graph. One of them is -4 and one of them is 7. Alright, so let me give you guys, just take a couple seconds and see if you can break down the polynomial. It doesn't matter which one you do first, which one you do second. Just break down with synthetic division with one of the zeros, and then break down your answer that you get with the other. You shouldn't have a remainder. Right away I can see from the graph, -4 and 7 are both zeros for that. And it doesn't matter which one goes first or second. If -4 is a 0, that means the linear factor is x plus 4. If 7 is a 0, then it means x minus 7 is a factor. So in any order, see if you can break those guys down. If you guys want to check that last one real quick, this is just what I did. I divided in the x plus 4 first. If you did the x minus 7 first, we should get the same result at the very end. The numbers just might look a little different depending on which one you did first or second. But we should end up with the same thing as the outcome after you've divided twice there. And so I got the factored. Actually, this one was a little bit nicer than the previous question because I just got x squared plus 81. And then all I did was set that equal to 0, subtract 81, take square root. -81 is a perfect square. In imaginary land, you're just going to have plus or minus 9i. That's why we couldn't see the other 2 solutions on the graph because they're imaginary. But I have all 4 answers here. So I got the -4, the 7, and then plus or minus 9i is actually 2 answers in one with that little plus minus symbol. Is anybody having a question or not getting that?